Hi, thanks for your question. Like I said, I'm sort of a novice on this, and I've been just in the last month or so been trying to learn it myself, actually. And so I've been watching and reading some videos on the subject, and it's good to have these types of questions pop up because it gets me to think about it too. And let's see if I can get this to work. So here I've drawn out uh, six lattices, six unit cells, I should say, six unit cells of a crystal, and I'm just showing it in 2D, okay? And this would go off in this direction forever, in this direction forever, and then back into the computer screen forever too. I'm just showing a 2D image. And then I thought, well, I could choose a three-dimensional object like a clamshell. So we could have a crystal of clamshells. And so here's my unit cell. And like I said, I'm just showing the front face of it, and you would pretend that there is the other three-dimensional part of it, but we don't really need it. And we could just add clamshells in there. So here is my crystal lattice of clamshells. And like I said, all it really matters for XRD to work is that you have a unit cell, and each unit cell is identical to each other, and it repeats in every direction forever. And so if you look at this, inside of each little unit cell, they're all identical. So if I just take a slice here of this one, this is what it is. This is my unit cell. And so the important point here to sort of figure out is that your molecule or object or whatever you're doing, because you can do X-ray crystallography on DNA or viruses or whatever, is that the unit cell kind of repeats itself. And so nature will pack in to the unit cell whatever is the lowest geometry, lowest energy. And so I'm just drawing whatever I made up, but for any particular molecule, there may be pieces of the molecule that are not inside the unit cell that extend out into the next unit cell. All it really matters is that the unit cell, however it's stuck in there, whatever pieces of the molecule are in there, repeats itself. And so if I go here to the next slide, let's copy this. So I'll copy this, and then I'll just paste in like a whole bunch of them. 1, 2, 3, 4, 5, 6. So I'll just grab it. And so that was my unit cell. And so if I stick them all together, I should be able to reconstruct my crystal lattice of clamshells. And so the same thing would, and the clamshell is a three-dimensional object. And so the same thing would work with a molecule, uh, an organic molecule. So if I go over here, so if you go to the UNR's website, library.unr.edu, and I'm not sure if this is accessible from off campus, the database part, and you go to databases and you type in Cambridge and crystallographic in the database. And there's this one called WebCSD, and I'll click on that one. And then their compound name, we could type in aspirin. Let's do aspirin. And let's see, I'll just do this second one here. I think they're all the same, it looks like. And so let's zoom in on this. Oop. And you can see down here I've had unit cell chosen because you can do none and unit cell. And so for this particular organic molecule, let me zoom out here. Oh, I don't want spinning. Turn off spinning. Spin off. Okay. There we go. So here is the unit cell that somebody's determined by X-ray crystallography for this molecule, okay? And you can see definitely that, and so this is just one unit cell, and then you would have each unit cell repeating forever, and you can see parts of the molecule. Oops, if I can get it in the right geometry. Not all of one individual molecule is inside of one unit cell. And so all it matters is that the unit cell repeats itself. It doesn't matter what you put inside it. You can define the unit cell any way you want, just as long as it repeats itself. And the whole molecule does not have to go inside of it. So if I change this to wireframe, and then we can do like a 3 by 3 by 3 unit cell. So that's 27 unit cells. And so if I kind of, let's turn off the spinning here. Spin off. And I kind of manually spin it myself here. So you can see if I get it right about right there, okay? And let's turn that back to ball and stick. You can see that the unit cell is kind of repeating itself here. So here's, remember I said there's like 27 unit cells, and you can see here this basically looks like this, and this looks like this, so it's repeating itself, and that's what, and you have these planes that are appearing inside of it, and so that's what's going to, the X-rays are going to diffract off these planes. So I hope that kind of helps what you're looking at. You know, I think the important thing is that you just got to realize that the lattice points in a unit cell can be a group of atoms, and for one individual molecule, it doesn't have to all fit inside that unit cell. It can extend out. All it really matters is that you can devise some unit cell that's repeatable.